Oh, self-help electronics. And you're going to try and understand this before you're really well grounded in trigonometry. How are we going to do that? Well, let's see. Let's see if this diagram helps us out any. Oh my, oh my, oh my, oh my. Here's series resonant condition. Oh my. Omega. And phase. What are these other situations? Well, here we have a voltage. Ooh, AC circuits. Now, what if this is a DC circuit? Well, if this is just a DC battery, then that's just going to flow through the resistor and the current's going to stop and it's going to be zero. And if we apply a DC circuit to this coil, then that's just going to be whatever the resistance of the coil is. No big change. If we hook a DC circuit up to a capacitor, then the charges are going to flow one way or the other, and this is just going to be the potential of the battery, so no current flows. But what if we apply an AC voltage? Let's just put a little sine wave on there and see what happens. Well, for the resistor, it's just going to be flowing back and forth, back and forth. Now, how is that current going to be flowing if you've got a separation between these plates? Well, the current's going to come, the voltage is going to come one way and then the other on these plates. So the charges are going to be attracted or repelled, and as they're attracted, repelled, then you get a sine wave straight over here in exactly the same phase relationship as our source voltage. What about a capacitor? Well, as the current flows rapidly here, the voltage is low. And as the current slows down, the voltage is high. So that means that the capacitor is 90 degrees out of phase with the resistor. And because of that, we have this angle. And there's an angle here. So what's this angle all about? It seems very mysterious. You've got angles of currents and voltages. And just to finish this off, let's replace the capacitor with a wire, and I've got an AC voltage here. Well, as this comes in, as the current flows rapidly, the coil in its windings and magnetic field repel that. So the voltage is high here first. For the capacitor, the voltage was 90 degrees behind. With the inductor, it's 90 degrees ahead. So what if we take out the resistor altogether and put an AC signal on here? Well, this acts like, at the resonant frequency, this acts like a straight wire. So at the lowest, we get the most current at resonance when the voltage is going back and forth between the two. Now, just to point out, this whole video segment is to point out why the mystery of the angle comes on before you actually have calculus and trigonometry to handle it correctly.